Hello and welcome to today's lesson on polyatomic nomenclature. Today we're going to expand on our previous lesson on binary nomenclature, which focused on two atoms bonded together, two types of atoms bonded together. Today specifically we're going to talk about oxy-anions, which are just oxygen containing anions, which are negative ions. So oxygen for oxy, anions for negative ions. And again, your normal ion is from an element on the periodic table, right? So for example, fluorine ionizes, gains an electron, becomes fluorine 1 minus when it ionizes. These polyatomic ions are similar to compounds in the sense that there are multiple atoms bonded together. So these are a group of atoms covalently bonded together that act as a unit and carry a positive or negative charge. And the ones we're going to talk about today specifically have a negative charge and contain oxygen atoms. So an example and a comparison would be carbon dioxide. CO2 is a compound, and its structure looks something like this. There's a very similar oxyanion called nitrite, and its formula is CO2, but it has a 2 minus charge. And all that means is it's very similar to the carbon dioxide molecule, but it's carrying 2 extra electrons. Just like your oxygen atom carries 6 electrons, the oxygen anion carries 8. So in this case, the carbonate anion is very similar to your carbon dioxide molecule, but it carries 2 extra electrons and therefore a 2 minus charge. So anytime you see this negative charge, you would assume that it's a normal atom, it's a normal covalently bonded atom, compound, with extra electrons depending on what the charge is. So 2 minus would have two extra electrons, 1 minus it would have 1 more electron than it normally would. Or if it had a 1 plus charge, it would have actually 1 less electron than it normally would. So again, these are similar to compounds in that they're covalently bonded atoms, but they have these charges on them which make them act like normal ions, similar to the oxygen anion, as an example. Okay, and when we talk about oxyanions, since we're talking about nomenclature, there are some rules on how we name these. Okay, so for every one of the oxyanions that we talk about, there's a main oxyanion, so one that's most common, and that will be the 8 ion. So for example, if it's dealing with carbon, it would be the carbonate ion, right? Carbon being the one, we just drop the ending and put 8 on. Okay, same idea. But if we have 1 less oxygen, so in this case the main oxyanion was CO3, 2 minus. If we have 1 less than that, so we have CO2, we call it the carbonate ion. We can also have 2 less than the main, which in this case would be the CO, 2 minus, and it's called the hypocarbonate ion. If we have 1 more than the main, so in this case that would be CO4, 2 minus, we call that the percarbonate ion. And so it works for any of the common anions on the periodic table. So in this case we used carbonate. But if we use nitrogen, it would be nitrate would be the main, nitrite would have 1 less, hyponitrate would have 2 less, and pernitrate would have 1 more oxygen than the main. The charges are never changed, so any of the carbon oxyanions will always have a 2 minus charge. The number of oxygens may change, the charge on it will not. Now, there are a lot of these common anions, and so you can see a lot of the oxyanions with a 2 minus charge are here. Sulfate has 1 less, chromate, oxalate, thiosulfate. We see some other non-oxyanions. Okay, you see some with 1 minus charge, chlorate, nitrate, permanganate. There are a lot of them, and there are a lot to remember. So what we have is a periodic table of ions with nomenclature keys here that we'll use for the rest of the year. I'm just going to zoom in so you can see that a little bit easier. And there's some tricks to using this. So the first is down here on the bottom right. You can see this first line is the number of O's in the 8 ion. So if you remember, the 8 ion is the main oxyanion. So we talked about carbon and carbonate. We noticed that carbonate had a CO3 2- in the 8 ion. And any oxyanions in this column will have 3 oxygens on the main oxyanion, which means they'll have 2 on the ite ion. It would have 1 in the hypoite ion. And they have 4 in the percarbonate, or whatever it happens to be, ion. The second of these rows indicates the charge on all of those. So we talked about carbonate. It had a 2- charge. And you can see in this row, there's a 2 there indicating that. If you look at this column, the same rules apply. You have 4 oxygens on the main. In this case, it would be phosphate, right? And this is 3-, so the negative charge, or the charge on all of these, is 3-. Okay? If I were to talk about, so that would be phosphate. And that's the main oxyanion for phosphorus. Same rules apply here. Again, sulfur, SO4, 2- for sulfate. Chlorate, SO3, 1-. Okay. Now there are some exceptions, and nitrogen is the main one, and we can see that one come up over here. So nitrogen does not follow the rule of this column. Nitrate's main is NO3, 1-. Okay. And normally if it was in this column, it would follow these rules. So nitrogen is an exception to following those rules, but all the other ones here, unless highlighted in green, will follow the rules of down here. Okay. The exceptions to this rule are also up here. These are some weird ones that don't follow the oxyanion rules, and any of those might show up. Okay. Along with this is the naming key that we talked about. Okay, so if we go back to phosphate and we look at what column it's in, the 4 and the 3, the main oxyanion is PO4 3- based on our 2 rows, and it's the main one, so it's phosphate. Right? And this chart will always be here, you just have to be able to read it. The phosphite ion has 1 less oxygen than the main, so it would be PO3 3-, and that's phosphite. Hypophosphite would be PO2. And if we would have 1 extra than the main, we would have PO5 3-, and that would be perphosphate. Okay. And again, the rules here for bonding are all the same as for any other anion. So if I had, for example, sodium phosphate, you just pretend that this ion travels like any other anion that we've discussed. So I would write Na1+, I would write my phosphate, and then I would just use cross rule to determine the formula. So I would have Na3PO4. Okay. Similarly, working in the opposite direction, if I had, as an example, Mg3PO2, notice I put brackets around the entire anion using that cross rule. So if you look at magnesium, it's 2+, phosphite is that 3-, the 2 comes down, the 3 comes down, Mg3PO2, and again, the 2 from magnesium goes outside the brackets, indicating that I have 2 total hypophosphite anions. And so again, naming this is the same. I take my first metal that's listed, becomes magnesium, and I just indicate, now I just determine which one of those it is. So I see that it's it's a P. Okay, so phosphate would be the main. I see that phosphate has 4 O's. I have 2 less than that, so this might be the hypophosphite anion. And since we've already indicated those names, there's no change in suffixes or prefixes. So this just becomes magnesium hypophosphite. Thank you, gentlemen, and we'll see you in class.